You ever get that strange feeling, when you're lying on your back on a summer night, staring up at the stars? You can't help but realize just how unbelievably massive the universe really is. It's breathtaking, sure, but it's also kind of depressing. Because what's the point of all that space if we'll never actually see it? Welcome to Rivo TV, where we dive deep into the biggest mysteries of our universe. Think about it. Let's imagine that tomorrow, our most advanced telescopes discovered another Earth. A twin planet, blue oceans, green forests, breathable air, everything humanity could ever dream of. Sounds amazing, right? But here's the painful truth, it wouldn't even matter. Because we could never get there. Escaping our own galaxy alone is a journey that would take not just lifetimes, but billions of lifetimes. Our closest galactic neighbor, the Andromeda Galaxy, sits 2.5 million light-years away. Now, let that sink in. If we launched a probe today, traveling at a mind-blowing 28,000 kilometers per hour, it would still take nearly 95 billion years to arrive. For perspective, the entire universe itself is only about 13.8 billion years old. Even if we somehow cracked the speed of light, you'd still be looking at a 2.5 million year trip. Hopeless, right? Almost makes you wonder, why bother even looking? But what if there's a cheat code hidden in the universe? A cosmic shortcut. Something that could take you across millions of light years in the time it takes to sip your morning coffee. Well, that's where things get exciting. Because scientists actually believe such shortcuts might exist. They call them wormholes. You've probably seen the movie Interstellar. Matthew McConaughey's crew escapes the boundaries of our galaxy by slipping through a wormhole parked near Saturn. They cross a distance of millions of light-years in minutes. And while that sounds like pure Hollywood fantasy, the truth is, it's rooted in real physics. So what exactly is a wormhole? To understand it, we have to go back to one of the greatest minds in history, Albert Einstein. His theory of general relativity told us that space and time aren't separate things. Instead, they're stitched together in a single fabric we call space-time. And giant, massive objects, like stars or black holes, bend and twist that fabric. That bending? That's what we feel as gravity. Einstein's equations were insanely complicated. He couldn't even fully solve them himself. But in 1916, a German physicist named Karl Schwarzschild found one of the first exact solutions. His math showed what happens if you squeeze an enormous amount of mass into an infinitely tiny point. What you get is a black hole, a place where gravity is so extreme, not even light can escape. And here's the crazy part, Schwarzschild's math was so good that a full century later, when we finally photographed a black hole in 2019, it looked exactly as predicted. But those same equations had another possible solution. Just like in school, when you solve a quadratic equation and get two answers instead of one. The second answer pointed to something just as mind-blowing as black holes. Wormholes. In 1935, Einstein and physicist Nathan Rosen published a paper describing these shortcuts. That's why the official name for wormholes is the Einstein-Rosen bridge. Now, instead of saying, "Picture this," let me give you an easy way to imagine it. Grab a sheet of paper. Draw two dots on opposite ends. The shortest path between them is a straight line, right? But fold that sheet of paper so the two dots touch. Suddenly, the distance is 0. Punch a hole through the spot where they meet, and boom, you've created a shortcut. That's what a wormhole is, a tunnel through folded space-time. And while it's hard for us to imagine folding the universe itself, we actually deal with a similar concept every day. Take flights, for example. If you're flying from New York to Delhi, a straight line on a flat map would seem to take you across Europe. But pilots fly way up north, over Canada and the Arctic. On a 2D map, it looks longer. But on the 3D globe, it's actually the shortest route. Wormholes work in that same way, just on a universal scale. Fast forward to the 1950s, physicist John Wheeler gave these cosmic tunnels their catchy name, wormholes. He compared it to a worm burrowing through an apple. The worm doesn't crawl around the surface, it digs straight through, taking the shortcut. Now, let's say we actually had one. What would it look like? Not like a simple tunnel. From the outside, a wormhole would appear as a sphere, bending light in bizarre ways. Step inside, and everything would twist and warp around you, exactly like how it was shown in Interstellar. In fact, the filmmakers consulted real physicists to make sure the visuals matched Einstein's math. Here's the catch, though. We have no proof that wormholes exist. They're purely theoretical. But if they did exist, they wouldn't just allow shortcuts across space. They might allow shortcuts through time. Imagine leaving Earth and arriving on the other side of the galaxy before the light from your own launch even caught up to you. So how would one form? The math suggests you'd need unbelievable amounts of gravity to rip open a hole in spacetime. And we only know one kind of cosmic monster powerful enough to do that, black holes. Which creates another problem. Fall into a black hole, and you don't come out. That's not a shortcut, it's a one-way trip to nowhere. Unless, there's something on the other side. That's where the concept of a white hole comes in. If black holes are like cosmic drains, pulling everything in and never letting it out, then white holes are the exact opposite, cosmic fountains that only blast things outward. Nothing goes in. Some scientists even speculate that the Big Bang itself might have been a white hole, unleashing all the matter and energy of our universe in an instant. The late Stephen Hawking even theorized that when black holes eventually die, the information they consumed might erupt back out of a white hole. Of course, not everyone agrees. White holes seem to break the known laws of physics, reversing entropy and making the universe run backwards. But here's the thing, people said the same about black holes once upon a time. And then we found them. In fact, back in 2006, astronomers witnessed a mysterious flash of brilliant white light in the sky. It appeared, then vanished. It didn't behave like any supernova we've ever seen. To this day, some believe it may have been a white hole briefly blinking into existence. Now, while we haven't stumbled across an actual space-time wormhole yet, scientists have been experimenting with the idea here on Earth. In 2015, researchers in Spain created what they called a magnetic wormhole. Using exotic materials, they made a magnetic field appear to travel from one point to another invisibly, as if through a tunnel. Not the real deal, sure, but proof that the concept works, at least on a small scale. And wormholes aren't the only faster-than-light idea out there. There's the Alcubierre drive, a theoretical engine that wouldn't actually move a ship faster than light, but instead compress space ahead of it and expand space behind it, basically surfing a wave of warped spacetime. If it worked, you could technically beat the speed of light without breaking the rules of physics. Will humanity ever step through a wormhole? Will we ever ride a warp drive across the stars? Nobody knows. But if history has taught us anything, it's that the wildest ideas in physics, black holes, gravitational waves, eventually prove themselves real. And if that happens with wormholes, the universe is going to feel a whole lot smaller, and infinitely more incredible. This is Rivo TV, and if you enjoyed this journey through the cosmos, make sure to stick with us. Because out there, beyond the stars, the universe is hiding mysteries we can't even imagine yet. And you can bet we'll be here to uncover them, one story at a time. Until next time, keep looking up.